Day 50, Honors Physics, Conservation of Momentum, problem number 19. Here we have two freight trains. I have an overhead view here on the left. They're going to collide, and this will be a straightforward application of conservation of momentum. So we have to figure out the total momentum before the event, and it's real simple in this case. We have the 30,000 kilogram car traveling south at 3 meters per second, so 3 times 30,000 is 90,000 units of momentum southward. The other car, 5 times 40,000, all standard units there, has a total momentum of 200 kilograms meters per second north. In this case, we don't care about the change in momentum of either car specifically. We're looking at the total momentum here. Total momentum is 110,000 units north. Technically, you could call the 90 negative, I guess, and a 200,000 positive. So if you want the north direction to be positive, you have a positive 110,000 kilograms meters per second. But the fact that I've stated north, I don't need to worry about positives and negatives. So that is what's conserved down here in this rectangle. That momentum cannot change for the system of two cars. And this is going to be an inelastic collision. We know that because they couple together, they stick together. So essentially all you do is take that value and plug it in for your total momentum afterwards, because they're now stuck together. So that's the total momentum of the two cars stuck together system, equals the total mass, which would be what, 70,000, 40 plus 30, times V3. In other words, the post-collision velocity. So do the math there, get V sub 3. And that will be your answer. Now, in part B of the problem, it says how much energy is lost or transferred to heat. What you would do is you would figure out the kinetic energy of each car before the collision. So you could figure out KE1 for the 30,000 kilogram car, KE2 for the 40,000 kilogram car, add those together and get KE total before. It's going to be the sum of those two kinetic energies. And then you would come over here far on the right and figure out KE3, the total kinetic energy of that 70,000 kilogram car, just plugging into the 1/2 mv squared, and then compare what you have after the collision to what you have before the collision, subtract the two numbers to figure out how much kinetic energy was lost, because all we're worried about here is kinetic energy.